How's it going, everyone? Vlad here, and today we've got a very special and interesting video for you. As you know, through Solus PLC, I've been teaching and creating a lot of content on a variety of different platforms, from Rockwell to Siemens to Opto22, Phoenix Contact, and a couple of others. And ultimately, we have a lot of technical tutorials, written tutorials. We also have a lot of different videos, and we have entire courses on different platforms. Earlier this year, as some of you may have heard, there was a very big announcement on the Siemens side, which was the release of the G2 version of their S7 1200 PLC. And so, fortunately, I have been able to receive one of those PLCs. And so, we will be creating a variety of different content and tutorials on the hardware as well as the software side as to what the differences actually mean from the first generation to the second generation. And so one of these videos was me talking to Luis Narvaez, which you will be looking at today, but basically asking him a lot of the difficult questions on the features, but also what does that ultimately mean for the integrators, for the OEMs, for the machine builders, and for the end users. So without any further delay, I want you to watch the video. If you have any questions on that side, if you work extensively with Siemens or any other platforms, make sure to let me know what you would like to see. We have some technical videos. Like I said, we have some technical tutorials posted already on the website. I will be sharing quite a bit of information on my side as well as I continue to do work in manufacturing and industrial automation, looking at some of these different systems. So don't hesitate to reach out if you have any questions, if you want me to pass them to some of the technical Siemens professionals as well. And thank you so much for your time. Hello, everyone. Thank you so much for joining the conversation and the stream/episode. Today, I wanted to talk about a very important and interesting announcement that happened earlier this year in 2025, which is the new generation of the S7 1200 PLC from Siemens. And on the conversation with me today, I have Luis Narvaez, who's going to be answering a lot of my questions, but ultimately answering the broader questions that may come from engineers, for production managers, plant managers, machine builders, OEMs, and distributors as to how this new PLC makes an impact in a variety of applications. What does it mean for the previous generation of PLCs? And ultimately, what is possible? What kind of different features there are? And so, my goal, at least, is to release different segments to answer some of those topics, whether that's on the safety side, on the motion side. And I know that Lewis has worked on a fantastic skid that I saw in person earlier this year at Automate, which will also be at SBS in Atlanta. But ultimately, we will also do a more thorough technical walkthrough of all the different components that interface the S7 1200 G2. But today, we're going to keep it a little bit more higher level, but still talk about, again, the hardware as well as the integration. So I also have a couple of videos, obviously, on getting started, on connecting it into the new TIA Portal version 20, which you can also download as a trial for free, which I've done so through the cloud as well. But without any further delay, before we dive into that, Lewis, could you give us a bit of an introduction of yourself, please?
Yeah. Thanks, Vlad. So happy to be here. Thanks for having me on here. Just a quick background on myself. I'm Luis Narvaez from Siemens. I'm the product portfolio manager in Siemens USA for our SIMATIC controllers, and been doing this for a few years now. Probably I think before COVID. So it's been about 5 or 6 years now that I've been in this role. I've served many different roles within the organization at Siemens, mostly technical early on, and then kind of merging into marketing and product management now. So really excited to talk about some of the new innovations we've had on the controller side, and just overall the topics, safety and motion and things like that, and the direction we're going in the future.
So let me ask you, I guess, a first question when it comes to the general overview of features of the new controller, right? So you've done a couple of presentations, some of which I attended, and we'll probably include the links to those sessions in the description. But if someone's completely unfamiliar with the new generation of the PLC, what can they expect, I guess, to see in this release?
Yeah, I mean, if you're just getting into Siemens and you're starting off and you're not familiar with our controller lineup, the S7 1200 G2 is a great place to start. It's what we would classically have considered our basic controller. It's brick style, is like with what you showed earlier, has some integrated IO built in, very cost effective. So it's a really great place to start. And it's essentially the same, it uses the same programming environment as the advanced controller or SM 1500, same instruction sets and everything. So the great thing is that, like I said, if you're just starting out with Siemens in general, it's a great piece of hardware to start with. It uses the same engineering tools that you would typically encounter in the field for the larger applications. So again, it's really great. What's new about the 1200 G2, and G2 stands for Gen 2, Generation 2. Pretty straightforward. We decided to keep the name S7 1200 instead of doing something like, I've heard people say, like, why not call it S7 2200 or S7 1300 or whatever. Um, and I think that the reason why we decided to stick with S7 1200 and just add a G2 at the end is S7 1200 has been around for a long time, been about 15 years. It's been on the market, and it's known for its reliability. It's known for its performance and functionality and name in the market. So we wanted to maintain that recognition going into the second generation. That's really the core behind the naming. And it goes without saying that with this G2, we've raised the bar a little bit more. When we were talking about compact PLCs, I wouldn't even classify it as a basic PLC anymore because there's a lot of advanced features in there that you typically wouldn't get with another PLC in that same price bracket, in that same form factor style, right? Some of the features, most notably, is motion. We're really excited to bring that to the 1200 G2. The G1 can do motion, but it's very limited in terms of just like single axis positioning. With the G2, we've now introduced what we would consider advanced motion functionality. Things like coordinated motion or control of kinematic systems like Cartesian portals.
Yeah, I guess I have a lot of questions for you on different features, but before we get there, right, you made a very important point, which is ultimately if you're getting into the Siemens ecosystem, there's a couple of options that you could go for, right? So on the lower end side, maybe you have the logo controllers, then you have the S7 1200 series, and ultimately the biggest, or I guess the most powerful controller, which is the S7 1500 series. So I wanted to maybe, again, for someone who's looking into the lineup, try to delineate what are some of the differences between those three lines, and maybe at which point would you recommend, hey, maybe this is an application that could be handled by a logo, and you need something a little bit simpler with just a couple of sensors versus now we're moving on to the G2 series. And maybe at this point, if we have a more complex motion, perhaps of an application, moving on to the 1500 series. Could you elaborate on that a little bit?
To answer your question, Vlad, I will say the 1200 G2 has certainly blurred the lines a little bit between the different families of controllers that we have. I will add that, we also have an S7 1500 controller that's in our distributed IO form factor, our ET200 SP controller. And that's essentially an S7 1500 inside a different housing, right? Exactly. 1500. Now, with the 1200 G2, what we did, not only did we increase the functionality, we obviously increased the performance. One way to kind of differentiate when you would use a 1200 or when you would use a 1500, it really depends on the application. And I know that's kind of a very broad, generic definition, but I say this because, like I said, it kind of introducing the 1200 G2 kind of blurred the lines a little bit. There are applications that you can certainly do it in a smaller S7 1500 controller, even an ET200 SP style S7 1500 controller that would totally be capable of handling, what a 1200 can do. There might be some IO that you need in the ET200 style form factor, or in the more modular S7 1500 style that's not available in the 1200 G2 or the S7 1200, what we would maybe call G1. That could be a scenario where you would go into a higher controller. There could be space constraints where the SM 1500 is just too big and you don't need high performance, then the 1200 G2 might be a better fit. One thing I will say is about 2 years ago, 3 years ago, we redesigned our S7 1500 internally, a little bit externally on the aesthetics for the display, but for the most part, it looked mostly the same. What we did for the internal redesign is we introduced a new processor, a multi-core processor, so that way uh, the PLC can run more efficiently, much faster when it came to PLC program execution, as well as processing exit communication functions and things like that. We also increased the memory of the S7 1500 controllers across the board, from SP all the way up to our 1518 controller, which is the biggest one, right? Memory and increased processing speed, updated the CPU and things like that, the whole architecture. Now, what that did is if you're looking at a chart with the S7 1200 and S7 1500, they were about here, right? So it's pretty clear in terms of like performance, what the difference was, and it scaled. 1510, it was very linear. So 1510, 1511, 1512, 1513. And as you got higher up on 15, performance got a lot better. Did with this hardware change is we raised the bar and we opened that gap. So the 1200 G1 was still here, chugging along in its 2010 architecture, and the S7 1500 got a buff. This buff was across the board, and what we did is we standardized on it. So every CPU model in the 1500 family has the same performance benchmark
Okay.
between the different ones as the integrated memory, or really application size at that point rather than performance and application. So what the 1200 G2 basically does is it closes that gap a little bit more. So performance wise, it's still not as fast as an S7 1500. It's faster than an S7 1500 low end that was, let's say, previous generation, right? Before the hardware buff, but it's not faster than the current S7 1500s that we're bringing to market today. So again, that kind of blurred the lines a little bit, especially if you're a customer who was maybe used to using like a 1510 SP and was satisfied with the performance there with the previous generation of 1510 SP. Those customers might say, well, now I can run it in the G2. It's still faster than what I had before, and it still has efficient memory than what we were using before. So our application hasn't changed. So it's a little bit weird. I don't technically I don't know if I'm supposed to say that, but that's the honest truth that, it's a little bit blurred. The 1200 G2 at the end of the day is, I wouldn't consider it a basic controller anymore because it does have a lot of advanced functionality. Of course, when it comes to motion, that's a clear application qualification, a thing that we can quantify a little bit more, meaning how many axes are you trying to control? What kind of motion application is this? Function, what you would need interpolation. Is it a Cartesian portal, or is it a Delta picker, or is it Scara robot? Is it a 6-axis articulated arm? What's the use case, right? And that one is a little determine, okay, this goes into a 1500T or this one goes into a 1200.
Let me ask you, I guess, like a follow-up to dig in a little bit deeper on the end user side, right? So obviously there's going to be different use cases and it's difficult to generalize, but I guess I see maybe three different scenarios, right? So you're going to have maybe a facility with an existing installation of S7 1200 first generation PLCs who's maybe thinking, well, should we be upgrading? Should we leave like whatever is currently in place the same? Do we need to migrate to, TIA Portal version 20? And can we get some benefits as a result of that migration? Then scenario two is obviously more, I would say, machine builder oriented, but even an end user who's designing new machines going into, end of 2025, maybe beginning of 2026. Should we be redesigning some of our schematics to include the new version or again, stay on the G1 revision of the S7 1200 series, which will be supported into the future? And I would say, again, like question three, and you brought this up a little bit, if we have, or if we are in the process of deploying in certain instances S7 1500s, well, maybe there's some cost savings for us to, go to this new version of the G2 S7 1200 PLC to save on cost, maybe to save on IO. obviously there's going to be some redesign required. So if we're looking at those three scenarios, could you maybe elaborate what the customers should be thinking about or even like questioning as they go through those potential transitions or considerations?
Yes, absolutely. So in the first case, we're talking about migration, right? You're an end user, you've got an existing machine installed, and even though maybe it's running reliably or maybe it's not running as so reliable as you'd like, it's a ticking time bomb. And you know you have to do something about it. I'm more of the camp of forget thinking about migration. Let's think about modernization. And there's a distinct difference that I like to classify between the two, right? Migrating is I've got a 1990 Corolla and I'm going to get the 2025 Corolla. And while there's some features that make it faster or more convenient and things like that, maybe the 2025 doesn't have everything that I want in, like, let's say, a Tesla. Maybe I want self-driving. Maybe I want over-the-air updates and things like that, right? I don't, whatever features in a Tesla that make it kind of above the just the new version of whatever it is I had before.
Mhm.
Migration is kind of that same conversation of, do I just stick with what I have and just go with the newer, or do I consider something that is more advanced? And for me, I always like to look at it as, what is something you would like to get out of this machine or this piece of equipment that you're currently not getting? What would you like to see? Okay, this machine produces 100 parts a minute or 100 parts an hour or whatever. What's stopping it from going to 200 or 300 parts an hour? You look at those requirements and then you start to kind of filter out a little bit of what you're looking for in your control system of the future for that piece of equipment or for the line or for the factory and so on. So performance is one of those things, right? That's a checkbox. What do you need to make this throughput faster? Well, there's a large part that's very, we have a quality inspection part of this machine that's very manual and stuff like that. Okay, so you want to automate that, right? So now you need something that is high performance. You need something that can maybe handle motion. Maybe you want to put a robot or some sort of moving camera that can inspect the parts while they're moving down the line, right? Uh,
Mhm.
Something with motion. Okay, this machine was built in 1994, 1993. We have safety relays in there and maintenance guys override it by, hot wiring some jumpers and stuff like that. We had a few injuries, and that caused the machine to be down for a little while it was being under investigation. We'd like to, obviously make it safer and prevent for people to override the safety mechanisms that we've put in place, both mechanically, electrically, and in the software. Okay, so you need integrated safety in your automation system and software defined safety. So those kinds of things are qualifying questions to help you figure out, okay, these are some of the steps I need to take this machine to the next level. It's not just about replacing the PLC with equal, that's not modernization, that's migration, 1200 G2 is a great option, whether you're using 1200 G1, whether you're using a different vendor. It definitely offers a lot of those benefits that you may not get in the newer version of what you are currently using. Or maybe there isn't a newer version. Maybe that company went out of business and you're just kind of open for whatever. Also, Tow G2 is cost effective. Yes, it's marketed heavily as a very cost effective platform for high performance, but don't let cost be the only factor in your decision. There's other factors, that the cost of downtime, the cost of maintenance, the cost of an injury or something like that, can you really afford bypassing those costs and ignoring those costs if you try to make a decision based off of upfront capital cost of the equipment? So just something to
Yep.
consider also.
I speak to that last point of yours all the time, right? It's an ongoing debate, I think, in the industrial automation, but in the manufacturing sector in broad, I think you can certainly save on the hardware side and in many different ways, but usually it is a, how would I call it? I guess a trap for newer players because you will pay a lot more in those costs, over the life cycle of your equipment, which is in many cases decades, right? So even a couple of hours of downtime is going to be way over the cost that you've saved, initially on the hardware side. And I think, let's be honest, as electrical engineers, in theory, you could program an IC on a circuit board and wire that in through the entire plant and make it work maybe for the first couple of days, but the technical debt of going that route is just, I don't know. I guess obviously it's an extreme example, but for anyone considering like platforms, I think it is important. And there's always going to be a cheaper option on the just pure hardware software side, but that doesn't mean like over the whole life cycle of that equipment, it's going to be cost effective. What about the other two, I guess, scenarios? If you're a machine builder that is, has been standardizing on a controller and is looking to maybe figure out a way to either transition or I guess add some of those functionalities that they didn't have before. And I guess I also want to learn, what does it take to migrate, right? So if you have a software that's been designed for the previous generation of controllers, what does it take to actually now utilize, the G2 series, I guess from a software and hardware standpoint, right? Because I can tell from the physical layout, the IO is not going to be the
Right.
same. So I guess, could you expand a little bit more on that side as well?
All right. So for the second scenario where we're talking about a machine builder who's got an existing system. Now let's take the machine builder that's currently using an S7 1200 Gen 1, for example. What kind of
Mhm.
tools do we have to help them migrate? There's a couple things. So we have a migration tool that will help you convert your application code, your TI Portal project and everything from a 1200 G1 to a 1200 G2. That's a tool that we released as an add-in to TI Portal starting with version 20. So when version 21 comes out, you'll be able to also use this tool and 22 and so on and so forth. On top of that, we also have a migration guideline document, and this helps you convert the bill of materials a little bit. In the future, there'll be a tool built into our TI selection tool, which will help you migrate your S7 1200 Gen 1 hardware bill of materials to the recommended Gen 2 equivalent.
Gotcha.
So this
If I could,
yeah,
I was going to ask if I can expand on that a little bit, right? So when you migrate on the software side, are there any gotchas or watchouts from maybe like very early versions of TIA Portal, or some instructions that might be a little bit more complex or have been changed? Anything you can speak to on that side?
there may be situations where you have to do some manual adaptation of your logic into the 1200 G2. For example, today, if you have certain motion instructions that were used in the 1200 G1, those are not the same type of motion instructions that are in the G2. The G2 is exact software kernel as our S7 1500, whereas the 1200 G1 is a derivative, like a 95% equivalent to S7 1500. So that
Gotcha.
5%, there's certain instructions that may not convert one to one. In those cases where you want to migrate, right? There's two things that's included in this migration tool. There's the migration checker, which will basically check your project if it's migratable and inform you of some things that you have to manually adjust.
Mhm.
The second part is the actual migration tool, which will perform the migration for you, which also spits out a report of what migrated, what didn't migrate, things like that. So
Gotcha.
there's those tools that will tell you what did not convert and what do you need to do to address that. And sometimes it's really minor things like, I don't know, timers or certain instructions that you can just drop in replacement of the predecessor.
Mhm.
Uh, just some things there. So far, we haven't had any issues with customers using the migration tool. I actually got feedback this morning from another client where they started designing a new machine. This is a new machine with the 1200 G1 and was not aware that there was a Gen 2. We made them aware of it. They're like, okay, I've done all this engineering though on my G1 system. Can you help me get this to a G2? And just in literally minutes. We just took their application code, ran it through the migration tool, and like, okay, it's done. All you need to do is download it to the G2 and test it, right? So that was a really nice situation there. In the case of like documentation, because that's something that people sometimes forget too, is documentation. We actually had this add-in within TI Port that's been available for TI Port for a while called Code to Docu, which actually allows you to create documentation on your PLC code, on what's running on the PLC, and be able to send that to or modify it so to your needs. So if you want to integrate that
Really?
into kind of service documentation, or if you wanted to bring that into, whatever documentation you want to create, you can take that logic and it'll generate them. Uh, it'll generate a description of, let's say, custom function blocks that maybe you created. Things like
Yeah.
comments, the inputs, the outputs, what data types go in and out of the block, and things like that. So that will also help you recreate the documents that you've already done in the previous generation and do that again in the G2.
Interesting. Do you have an example, I guess, or if someone's interested in seeing what that
Yes.
actually looks like?
So this tab will take you to the application note in our support site that has an application example. So it has a TI Portal project that you can actually print the documentation. There's a PDF that you can see if you wanted to get a little better idea as to what the output of that looks like. So,
Interesting. And that's generated purely based on the logic that it scans from the program? Huh.
so let me trust for an example of it exports it in a docx. So that's the modifiable part, by the way, PDF or HTML.
That's pretty cool. That's like I know there's obviously a lot of trials on the AI side via like Copilot. I didn't know there was like a standalone app that allows you to just get that done.
So it's an add-in. So it's something you would install on top of TI Portal, and then you can run it directly from Portal. So this is kind of what it looks like in the PDF, where you show like the function block, the
Mhm.
parameters that feed in, the parameters that go out, and what that looks like, or the data types, description of it, what the default value is of that block. And then, of course, you could drop that into whatever documentation. It spits it out in a docx, PDF,
Mhm.
HTML, or HTML format, so you can modify it as.
That's really cool. Oh, I like that. I think it's definitely a useful feature. Let us, I guess we sidetracked a little bit. So you mentioned obviously there's the migration tool on the software side. Can you talk a little bit more on the bill of materials, right? So obviously the IO is not the same between the two generations. I guess what does it take to migrate and what's perhaps also to the same question available or perhaps needs to be more thought out when it comes to just, obviously I'm assuming like digital inputs is digital inputs just in a different form factor, but maybe there's some specialty modules that people should be paying a bit closer attention to when it comes to these migrations.
Yeah, so for right now, our plan is to release 100% migration from the G1 to the G2. I think it's pretty apparent that G2, the G1's been on the market for about 15 years now. G2 is a new generation, second generation. It's the ultimate successor to the previous generation, right? So our priority right now is to make sure that we're releasing IO cards and functionality that makes the transition from G1 to G2 a lot easier. Are we 100% there today as I speak right now? No. Um, so that is something that we're working towards. But one thing that we do have is what we have right now available today. We do have in the G1 documented what you can transition to. So this
Mhm.
migration guide is also a document that customers can use or to help determine what is the equivalent G2 variant. It goes from the power supplies to the CPU models to fail-safe CPUs, IO, as regarding the signal modules, what the equivalents would be, as well as both analog and digital temperature cards, signal board. So going from the Gen 1 to the Gen 2. So we do have some documentation to help with that, some charts to help with the migration, communication cards, things like that. Now, the one thing that you pointed out also is there is a notable difference in dimensions. So this is something that unfortunately we don't have a tool to help with redesigning your panel layout. I guess that really depends on the CAD tool that you use for your electrical design. It is something to take into consideration. Looking at here, right? um, We save a ton of space on the DIN rail in terms of comparing CPU to CPU, as well as IO cards comparison to the Gen 1. For example, a 1214C PLC on a G1 is 110 millimeters. On the G2, it's 80 millimeters. So it's about 27% savings on the DIN rail. That
Mhm.
allows, I mean, that space that you could either completely remove an entire DIN rail in a panel or put some additional modules, relays, whatever you need to on that DIN rail, should you need to. But the one main difference, and it is a little bit deeper, but that doesn't tend to be a huge deal breaker for customers or a huge issue. But what's something that you do need to consider is that it's about an inch height wise taller. So about half an inch on the bottom, half an inch on the top, 25 millimeters bigger on the height. So it is something to take into consideration, especially if you have a really tight cabinet that doesn't have a lot of air ventilation or a lot of space between the top of the CPU and let's say your wire tray, or let's say you got your Ethernet cables routed through there. You might need to take that bend radius into consideration. So unfortunately, we don't have a lot of tools to help with, again, redesigning the panel layout. That's where applications like ePlan and AutoCAD Electrical or just AutoCAD or whatever your CAD tool of choice is, that's where those can really help with redesigning that. One thing to also make note of is these CPUs have kind of switched on where the Ethernet cables are and when your power plugs are. So with the 1200 G2, the Ethernet cord is on the top. The Ethernet ports are on the top versus the G1. Yep, there you go. Versus the G1, Ethernet ports are on the bottom. So not terribly, again, a huge issue in most cases. Just means you have to reroute your Ethernet cord. It can be an issue, especially if you have a shorter Ethernet cord. So, yep, there's the depth comparison and the height comparison. Yeah. Oh, you can see it's about 12.5 millimeters on the top and 12.5 millimeters taller on the bottom. That may or may not be a huge difference, depending again on the installation.